What happens inside your body when you eat garlic right before you go to sleep? That question sounds almost too simple to be interesting, and yet the answer involves your cardiovascular system, your immune defenses, your gut microbiome, your blood pressure, your hormone balance during sleep, and a set of chemical reactions that most people have never heard of, all triggered by a single clove of a plant that humans have been eating for more than 5,000 years. This video is not about folklore or grandmother's remedies. It is about what the science actually says, what happens at the molecular level, what changes in your body during those hours of sleep when the garlic compounds are circulating through your bloodstream, and why the timing of eating garlic at night turns out to matter more than most people would expect. Here is the central idea of this video. Garlic is not just a flavoring agent, it is a delivery system for a specific set of sulfur-based molecules that interact with your body in measurable, documented ways. And when you eat it at night, just before sleep, those interactions happen during the most biologically active recovery window your body has in any 24-hour period. The question worth asking is not whether garlic is good for you in a vague, general sense. The real question is what specifically changes in your biology from that moment the garlic hits your stomach, through the night, and into the morning. That is exactly what this video covers, layer by layer, from the first chemical reaction in your mouth to what studies show happening in your arteries, your immune cells, your gut bacteria, and your blood pressure while you sleep. Before we get into any of that, let me ask you something, and I genuinely want you to think about it for a second. Have you ever wondered why so many traditional cultures across so many different continents, with no contact with each other, all independently arrived at garlic as something medicinal, something worth eating regularly, something associated with health and strength? That is not a coincidence. There is a biological reason buried in the chemistry of that small white bulb, and it starts with something that does not even exist until you bite into it. Garlic in its whole, intact form contains almost none of the compounds that make it biologically active. The bulb, sitting on your counter, is essentially inert from a pharmacological standpoint. Inside each cell of raw garlic there is a molecule called allicin, spelled A-L-L-I-I-N, which is a sulfur-containing amino acid derivative. It just sits there, stable and unreactive, doing almost nothing. Separated from it, stored in different compartments of the same cell, is an enzyme called alliinase. These two molecules are like two chemicals stored in separate chambers that are never supposed to meet under normal conditions. They are kept apart by the physical structure of the cell wall itself. Then you crush the garlic or chew it or cut it. In that single mechanical action, the cell walls rupture. Allicin and alliinase suddenly come into contact with each other for the first time, and within seconds, a reaction occurs. The alliinase enzyme converts allicin into a completely new molecule that did not previously exist in the garlic. That molecule is allicin. And allicin is the reason this video exists. Allicin is chemically known as diallyl thiosulfonate, and it is intensely reactive. It is the molecule responsible for the sharp, pungent smell of freshly crushed garlic. It is volatile, it is unstable, and it begins to break down within minutes of being formed, transforming into a cascade of related sulfur compounds, including diallyl sulfide, diallyl disulfide, diallyl trisulfide, ajoin, and several others. This cascade of compounds is what ends up circulating through your body after you eat garlic, and each of these molecules has its own set of interactions with human biology. Here is the first thing about timing that matters. Allicin formation requires mechanical damage to the cell, meaning chopping, crushing, or chewing. But once formed, it begins to degrade quickly. Heat destroys it rapidly, which is why roasted garlic has a completely different chemical profile and significantly reduced allicin content compared to raw garlic. If you want the full spectrum of compounds, raw garlic, crushed or chewed, gives you the highest allicin content. Letting it sit for 10 to 15 minutes after crushing, before consuming it actually helps stabilize some of the conversion, because the alliinase reaction continues briefly after crushing. Some researchers suggest this waiting period maximizes the yield. A small detail, but a meaningful one if you are trying to get the most out of it. Now, you swallow it. And this is where things get genuinely interesting in ways that most people never think about. Your stomach is an acid environment, with a pH that typically ranges between 1.5 and 3.5. Allicin is actually somewhat stable in acid conditions, which means a meaningful amount survives the stomach and reaches the small intestine. From the small intestine, the sulfur compounds are absorbed into the bloodstream with notable efficiency. Studies using breath analysis have confirmed this in a very direct way. After eating garlic, measurable quantities of garlic-derived sulfur compounds appear in exhaled breath within 30 minutes, because they are being carried in the blood to the lungs and volatilized during exhalation. The same compounds reach skin secretions, which is why eating garlic can make some people smell like garlic from their pores for hours afterward. This is not a side story. It is direct evidence that these molecules are circulating systemically, reaching tissues throughout the body, not just the digestive tract. So by the time you are lying down for the night, roughly 20 to 40 minutes after eating that clove, allicin-derived compounds are already in your circulation. And now your body enters a state that fundamentally changes how it interacts with almost everything. Sleep is not passive. If anything, it is one of the most metabolically complex states your body enters. During the first few hours of sleep, growth hormone secretion peaks, reaching its highest concentration of the entire 24-hour cycle. Your immune system shifts into a more active repair mode. Your blood pressure naturally drops in a process called nocturnal dipping, typically by 10 to 20% compared to daytime values. Your liver increases its detoxification and repair activity. Your gut microbiome changes its composition and activity patterns in ways that differ from waking hours. And all of this is happening while allicin-derived sulfur compounds are circulating through your bloodstream. The combination of garlic's chemical activity and your body's nighttime physiology is what makes the nighttime timing biologically distinct from eating garlic at noon, and it is the central idea that the rest of this video builds around. Now, I want to pause here for just a moment, because we are about to go into the cardiovascular evidence, the immune data, and the microbiome research, and there is genuinely a lot of ground to cover. If you have been finding this fascinating so far and you want to go even deeper into this kind of science, the way your food interacts with your biology at a molecular level, how nutrients behave differently depending on timing, combinations, and individual variation, we have put together something for that exact purpose. The Health Decoded Complete Pack brings together everything that videos like this one can only begin to touch. It goes into the mechanisms, the practical protocols, the questions that viewers ask most often about what to actually do with this information, with the science behind every answer. You will find the link in the description below, and you can also scan the code on your screen right now. It is a resource for people who want to go beyond knowing that something works and actually understand why it works and what to do with that knowledge. Now, back to what happens inside you during those night hours, because the cardiovascular data is where things get particularly surprising. One of the most studied effects of regular garlic consumption is its impact on blood pressure, and the research here is more substantial than most people realize. A meta-analysis published in the Journal of Nutrition in 2016 analyzed data from 17 randomized controlled trials and found that garlic supplementation significantly reduced both systolic and diastolic blood pressure in people with hypertension, with average reductions of around 8 millimeters of mercury for systolic pressure and 5 millimeters of mercury for diastolic pressure. To put that in perspective, those are reductions in the same range as some first-line pharmaceutical antihypertensive medications, though it is important to say clearly that garlic is not a replacement for prescribed medication, and no one should treat diagnosed hypertension with garlic alone without consulting a doctor. But as a biological phenomenon, those numbers are notable. The mechanism appears to involve multiple pathways. One of the primary ones involves hydrogen sulfide production. When the sulfur-containing compounds from garlic are metabolized by cells lining the blood vessels, they promote the release of hydrogen sulfide, a gaseous signaling molecule that causes smooth muscle cells in arterial walls to relax. This relaxation widens the diameter of blood vessels in a process called vasodilation, and wider vessels mean lower resistance, which translates directly to lower blood pressure. Hydrogen sulfide is not some obscure laboratory curiosity. It is a genuine physiological signaling molecule that your body produces endogenously, and garlic compounds essentially amplify its production. There is also evidence that garlic compounds inhibit an enzyme called angiotensin-converting enzyme, which is relevant because ACE inhibitors are one of the most widely prescribed classes of blood pressure medications in the world. They work by blocking this enzyme, which normally triggers a chain of events that causes blood vessels to constrict. Garlic appears to have a mild inhibitory effect on the same enzyme. Now think about the timing again. Your blood pressure naturally drops during sleep. That nocturnal dip is not just a side effect of lying down. It is a regulated process driven by the autonomic nervous system, and it is considered an important marker of cardiovascular health. People who do not experience adequate nocturnal dipping, a pattern called non-dipping, have significantly higher risk of cardiovascular events. The combination of garlic's vasodilatory and mild hypotensive effects with your body's own nighttime blood pressure reduction may create a particularly favorable cardiovascular environment during the hours when your heart and vessels are in recovery mode. This is a hypothesis that deserves more direct research, but the biological plausibility is strong. Beyond blood pressure, garlic compounds also appear to influence platelet aggregation, which is the tendency of blood platelets to clump together and form clots. Aggregation, one of the breakdown products of allicin, has been shown in multiple laboratory studies to inhibit platelet aggregation by interfering with platelet activation pathways. Diallyl disulfide and diallyl trisulfide show similar properties. Again, the sleep period is when your blood is moving more slowly through your vessels due to reduced heart rate and lower blood pressure, which is theoretically when platelet behavior matters. The anti-aggregatory effect of garlic compounds during this period is another layer of the cardiovascular picture. And then there is cholesterol. The research on garlic and cholesterol is slightly more nuanced than the blood pressure data, but a 2012 Cochrane review found consistent evidence that garlic reduces total cholesterol, with the effect being most pronounced in shorter-term studies. The proposed mechanism involves garlic compounds inhibiting hepatic cholesterol synthesis, specifically by interfering with an enzyme called HMG-CoA reductase, which is, once again, the same enzyme targeted by statin medications. Not the same potency as a pharmaceutical statin, but the same biological pathway. That is a detail that tends to make people stop and think. Let me pause here and ask you something. At this point in the video, has anything surprised you enough that you want to share it with someone? If it has, you can do that right now, and while you're at it, if you have not subscribed yet, this is the kind of content we make regularly. Real mechanisms, real data, no hype. Hit subscribe and you will not miss the next one. Now let us shift from the cardiovascular system to the immune system, because this is where the nighttime timing becomes even more biologically interesting, and where the traditional belief that garlic helps fight illness starts to have actual mechanistic support. Your immune system operates on a circadian rhythm. It is not static and constant. The activity of different types of immune cells peaks and troughs at different times of day according to internal biological clocks. Natural killer cells, which are a type of white blood cell that identifies and destroys virus-infected cells and cancer cells without requiring prior sensitization, tend to show increased activity during the nighttime hours. T lymphocytes and other adaptive immune cells also follow circadian patterns, with certain repair and memory consolidation functions occurring preferentially during sleep. Allicin and its derivatives have been shown in laboratory and human studies to have direct immunomodulatory effects. They stimulate the production of certain cytokines, which are signaling proteins that coordinate immune responses. They enhance the activity of macrophages, which are immune cells that engulf pathogens and cellular debris. And they have been shown to directly inhibit the growth of a wide range of microorganisms, including bacteria, viruses, and fungi, through mechanisms that involve disrupting their cell membranes and interfering with their enzyme systems. A notable study published in Advances in Therapy in 2001 tested volunteers who took a garlic supplement daily for 12 weeks versus a placebo group. The garlic group had significantly fewer colds, and when they did get sick, the duration of illness was shorter. This was a randomized, double-blind, placebo-controlled trial, which is the gold standard in clinical research. It is one study, and science requires replication, but it was rigorous and the results were internally consistent. The antimicrobial properties of allicin are mechanistically well understood. Allicin contains a thiosulfonate group that reacts with thiol groups in proteins, meaning it can bind to and disable proteins that contain cysteine residues, including many enzymes that pathogens depend on for their survival. This is a broad-spectrum mechanism, which is part of why garlic shows activity against such a wide range of organisms. Bacteria, including Staphylococcus aureus, Escherichia coli, and Helicobacter pylori, have all shown susceptibility to allicin in laboratory conditions. The clinical relevance varies, and in vitro results do not always translate directly to human bodies, but the mechanism is real and documented. At night, while your immune system is in a state of elevated repair activity, these circulating compounds are available to interact with immune cells in ways that may amplify immune function. The gut-associated lymphoid tissue, which is an enormous part of the immune system concentrated in the wall of the intestinal tract, is particularly exposed to garlic compounds because they are present in the digestive environment. This matters because a significant fraction of your entire immune capacity is housed in the gut. Which brings us to the gut microbiome, and this is a dimension of garlic's biology that most people have genuinely never thought about. Your gut contains somewhere in the range of 38 trillion microbial cells, primarily bacteria, but also archaea, fungi, viruses, and other organisms. This community, the microbiome, is not just passive cargo. It produces neurotransmitters, synthesizes vitamins, regulates immune responses, metabolizes drugs and food compounds, influences mood and cognition, and maintains the integrity of the gut lining that prevents harmful substances from leaking into the bloodstream. Garlic contains a type of carbohydrate called fructooligosaccharides, often abbreviated as FOS. These are prebiotic fibers, meaning they are not digested by your own enzymes and pass largely intact to the large intestine, where they serve as a food source for specific beneficial bacterial populations, particularly Lactobacillus and Bifidobacterium species. Studies examining the effect of garlic-derived FOS on gut microbiome composition have found that regular consumption is associated with increases in these beneficial bacterial populations and corresponding decreases in potentially harmful bacteria like Clostridium species. Here is where the nighttime timing intersects again. The gut microbiome is not static during sleep. Research published in the journal Cell Host and Microbe has shown that microbial populations in the gut follow their own circadian rhythms, with the composition and metabolic activity of the microbiome oscillating across a 24-hour cycle. The bacteria that are most active in fermenting prebiotic fibers tend to do so during the nighttime period of fasting and rest. Consuming the prebiotic fiber from garlic just before sleep may therefore provide the substrate at precisely the time when the beneficial bacteria most actively metabolize it. The byproducts of this fermentation are short-chain fatty acids, primarily butyrate, acetate, and propionate. Butyrate in particular is a critical fuel source for colonocytes, the cells that line the colon. It also has anti-inflammatory properties, helps maintain the integrity of the gut barrier, and has been shown to influence gene expression in ways that may reduce colorectal cancer risk. The production of these compounds during the night, while you sleep, represents a kind of biological maintenance process that garlic's prebiotic content is directly supporting. This is one of those details that makes you look at a clove of garlic differently. It is not just antimicrobial, it is also feeding the bacteria you want to keep alive and helping them do their work during the hours when your gut is in its own version of recovery mode. Now, there is something else happening during sleep that connects directly to garlic consumption, and almost no one talks about it. It involves sulfur metabolism in the liver. Your liver is one of the most metabolically active organs in your body during sleep. The nighttime period is when hepatic detoxification and cellular repair are at high levels. The liver processes toxins, repairs DNA damage, synthesizes proteins, and manages the metabolism of dozens of compounds simultaneously. Sulfur amino acids, which include cysteine and methionine, are central to the liver's detoxification pathways, specifically to a process called glutathione synthesis. Glutathione is often called the body's master antioxidant. It is a tripeptide, meaning it is made of 3 amino acids, and it is present in virtually every cell of the body, with the highest concentrations in the liver. It neutralizes reactive oxygen species, detoxifies harmful compounds, regenerates other antioxidants including vitamin C and E, and is central to immune cell function. The body's demand for glutathione is continuous, and its synthesis depends heavily on the availability of sulfur-containing precursors. The sulfur compounds in garlic do not directly become glutathione. The relationship is more indirect but still meaningful. Some garlic-derived compounds, particularly N-acetylcysteine-related metabolites produced during garlic metabolism, contribute sulfur to pathways that support glutathione synthesis. Research has also shown that some garlic compounds upregulate the expression of enzymes involved in antioxidant defense systems through a pathway called NRF2 activation. NRF2 is a transcription factor that acts as a master regulator of antioxidant and detoxification gene expression. When NRF2 is activated, it turns on the production of dozens of protective proteins, including glutathione-synthesizing enzymes, heme oxygenase, and others. This NRF2 pathway is the subject of intense current research in aging, cancer prevention, and metabolic disease because it represents a cellular defense system that declines with age and can be influenced by diet. Garlic compounds are among the relatively small number of food-derived molecules that have been shown to activate it. Eating garlic in the evening, when the liver is about to enter its most active processing period of the night, and providing sulfur precursors and NRF2, activating compounds at that moment, creates a timing that, at least in biological plausibility terms, is favorable for supporting these processes. This is not proof that eating garlic at night makes you live longer, but it is a mechanistically coherent reason why the timing is not arbitrary. There is one more dimension to cover, and it might be the most counterintuitive one, which is the relationship between garlic and sleep quality itself. Now, you might immediately think about the obvious issue, which is that garlic can cause digestive discomfort, acid reflux, or bloating in some people, and that these effects could theoretically disrupt sleep. That is a real consideration and worth acknowledging. People who are sensitive to fructans, a type of fermentable carbohydrate that includes fructooligosaccharides, may experience bloating and gas from garlic, and for those individuals, eating garlic before bed specifically might not be a good idea. Individual variation matters here, and this is not a one-size-fits-all recommendation. But setting aside individual sensitivity, there is an interesting potential connection between garlic's effects and sleep quality through its impact on a molecule called hydrogen sulfide, which we discussed in the context of blood pressure, but which has another role that is less well known. Hydrogen sulfide has been studied as a neuromodulator, Research conducted in animal models has shown that endogenous hydrogen sulfide influences neuronal signaling in ways that appear to promote relaxation and sleep onset. The mechanisms involve interaction with GABA-A receptors and potassium channels in neurons. This is a relatively new area of research, and the evidence is mostly preclinical, meaning it comes from animal studies, so we should be cautious about directly extrapolating to humans. But the existence of this pathway is documented, and garlic's well-established role in promoting hydrogen sulfide production in vascular tissue raises the question of whether it might have mild neuromodulatory effects as well. The research has not yet answered that question definitively for humans, but it is a line of investigation that exists. There is also the blood pressure reduction effect to consider in the context of sleep. High blood pressure at night is associated with sleep fragmentation and reduced sleep quality. If garlic's mild hypotensive effects contribute to a more pronounced nocturnal blood pressure dip, this could theoretically create conditions more favorable to uninterrupted sleep architecture, including the deeper stages of non-REM sleep where the majority of physical repair takes place. And here is something that brings together several of these threads in a way that I find genuinely striking. During deep non-REM sleep, the brain undergoes a process called glymphatic clearance. The glymphatic system is essentially the brain's waste disposal system, a network of channels around blood vessels in the brain that expands during sleep and allows cerebrospinal fluid to flow through brain tissue, flushing out metabolic waste products including amyloid beta and tau proteins, the same proteins whose accumulation in the brain is associated with Alzheimer's disease. This clearance system is most active during deep sleep and is dependent on adequate blood flow and vascular tone. The vasodilatory effects of garlic on cerebral vasculature, to the extent that they exist, could theoretically support glymphatic function by maintaining the vascular dynamics that this system depends on. This is speculative at the level of a direct causal chain from eating garlic to improved glymphatic clearance, and there is no human trial that has tested this specific hypothesis. But each link in the chain is individually supported by evidence, and together they form a picture that is at minimum biologically coherent and at maximum genuinely important. This is the level at which nutrition science becomes fascinating in a way that transcends simple advice. It is not just about whether something is good or bad for you. It is about understanding the body as an interconnected system of timed processes, where what you eat and when you eat it interacts with your biology in ways that have specific, mechanistically explainable effects. By now, we have covered the allicin formation mechanism, the cardiovascular effects, the immune interactions, the prebiotic activity in the gut microbiome, the sulfur metabolism in the liver, the NRF2 antioxidant pathway, and the potential sleep-related effects. But there is still something worth addressing directly, which is the practical question of how much garlic produces these effects, and what form of garlic actually delivers them. Most of the clinical research on garlic's cardiovascular and immune effects has used standardized garlic supplements, often expressed in terms of allicin yield or aged garlic extract, in doses equivalent to roughly 1 to 4 grams of fresh garlic per day, which corresponds to approximately 1 to 2 medium cloves. This is not a large amount. 1 clove of garlic before bed is within the range used in studies that showed meaningful biological effects. Raw garlic consistently produces higher allicin content than cooked garlic because allinase is destroyed by heat. However, aged garlic extract, which is produced by prolonged cold extraction, has a different, and in some ways complementary profile. Aged garlic contains compounds called S-allylcysteine and S-allylmercaptocysteine that are not present in fresh garlic, and these compounds have their own documented biological activities including antioxidant effects and potential neuroprotective properties. The two forms are not interchangeable, but both have research support. If you are eating raw garlic, crushing it and letting it sit for 10 to 15 minutes before consumption maximizes allicin yield, as we discussed at the beginning. Eating it with a small amount of fat may improve the absorption of some of the fat-soluble sulfur compounds. And if digestive sensitivity is a concern, starting with smaller amounts and building up slowly allows the gut microbiome time to adapt to the increased prebiotic load. Now, here is the question I want to leave you with, and I want you to think about this seriously enough to write your answer in the comments, because the range of responses to this question is actually quite interesting from a scientific standpoint. Of everything we have covered in this video, which mechanism surprised you the most? Was it the hydrogen sulfide pathway in the cardiovascular system? Was it the NRF2 activation and the connection to glutathione synthesis? Was it the microbiome circadian rhythm and the timing of prebiotic fermentation? Or was it something else entirely? Put it in the comments, because the answers tell a lot about what people find most surprising about their own biology, and that is genuinely interesting data. There is one more thing I want to say before we close, and it connects back to the very first question I asked at the beginning of this video. Why did so many cultures independently arrive at garlic as something medicinal? The answer, now that we have gone through all of this, is not mysterious at all. It is the chemistry. A plant that evolved these sulfur compounds as a defense mechanism against soil pathogens ended up producing molecules that interact in measurable, meaningful ways with human cardiovascular systems, immune cells, gut bacteria, liver detoxification pathways, and possibly even neural signaling. The traditional wisdom was not magical, it was empirical observation that preceded the molecular understanding by thousands of years. People noticed that something was happening when they ate it regularly. They could not explain the mechanism. We can now. And that, I think, is one of the genuinely wonderful things about modern nutritional biology. It does not debunk traditional knowledge so much as it explains it. It does not tell you that your grandmother was wrong for keeping garlic in the kitchen as medicine. It tells you why she was right, down to the specific chemical reactions in the specific cellular compartments where the actual work happens. What your grandmother knew through observation, and what 5,000 years of culinary tradition preserved without knowing why, is now written in peer-reviewed journals and metabolic studies. 1 clove of garlic, crushed, left for a few minutes, swallowed raw before sleep, sets off a cascade of molecular events that continues through the night, interacting with your vasculature, your immune cells, your gut bacteria, and your liver while you sleep. Not as a cure for anything, not as a miracle, but as a small, well-documented contribution to the biological processes that maintain your health across a lifetime. If you made it to the end of this video, you genuinely understand something about your own body that most people have never thought about. And if you want to go deeper, not just into garlic, but into the broader picture of how specific foods and nutrients interact with your biology at a mechanistic level, the Health Decoded Complete Pack is the most complete resource we have put together on these topics. It covers the science in a format that is organized, actionable, and built around the same rigor you have seen in this video. You will find the link in the description, or you can scan the code on your screen right now. If this video gave you something new to think about, subscribe so you do not miss the next one. Like the video if you found it worth your time, and share it with someone who still thinks garlic is just a flavor, because now you know it is quite a bit more than that.